Hello folks, today we are going to work on SOL A24C, which means we are going to TWISBAT solving equations containing rational algebraic expressions. So basically, what we've been doing the past couple days with finding LCDs, adding and subtracting rationals, that's going to help us today. So, how do we solve a rational equation? Well, I've broken it down into 5 steps. The first step is we need to find the LCD of the entire equation. So that's the first step. Then we need to take a look at what the domain restrictions are and keep those in the back of our mind. Then the key is that we want to multiply each term in the equation by the LCD. And what's going to happen when we do that is that all the denominators are going to cancel out, and then we can solve it. And our last thing that we need to do is we always need to check for any extraneous solutions against our domain restriction. So we need to see what was our answer, and is our answer not allowed because of certain domain restrictions. All right, so let's take a look at some examples. Our first example that you see here is 2 over x plus 3 is equal to 4 over x minus 2. So our first step is to find the LCD of the entire equation. Okay, so we have to look at all the factors of all the denominators just like we've done before. Well, this has a factor of x plus 3, so I know I need that. And this has a factor of x minus 2, so I know I need that. So this is the LCD. Step 2 is I need to note any domain restrictions. Well, my domain restrictions would come from when we're dividing by 0 on these. So we need to figure out what would make our denominators equal to 0. Well, negative 3. So we know that x cannot equal negative 3. And then a positive 2 from this one. So these are two things that x cannot equal. So if we get one of those as the answer, we know it's going to be extraneous. So the third step is to multiply each term by the LCD. So I want to multiply this side by the LCD, so x plus 3, x minus 2 times that, and multiply this side by the LCD. Okay, and let's see what happens. Step 4 says cancel out the denominators and solve. Well, let's see why that happens. If I'm multiplying x plus 3 times x minus 2 times this term right here, well, we need to think about this is over 1. So that means that x plus 3 can cancel with x plus 3, and all we're left with on this side is x minus 2 times the 2 from here. And on the right side, this x minus 2 cancels with this x minus 2, and we're left with 4 times x plus 3. And so what we've done is we've narrowed this down to a linear equation, and we can solve it just like we would normally do. So I need to distribute here, so this is going to be 2x minus 4 is equal to 4x plus 12. Okay. Since this is a linear equation, I'm just going to move all my x's to one side, so I'll move this over here, and so I have 2x, and I'll move the 12 onto this side, and then that is going to be equal to negative 16 when I subtract the 12. I divide, and I have x is equal to negative 8. Okay. So the last thing I need to do is, does my solution have any conflict with what my restrictions were? Well, I don't have any conflict because this is negative 8, and we knew that x couldn't be negative 3 or 2. So this is my solution, and that checks out. So x is equal to negative 8 for this particular one. So let's take a look at this next example. So this has 2 terms on one side and 1 on the other. So our first step is to find the LCD. So we want to find the LCD. If I look at this, this isn't completely factored, so I need to completely factor this first into x minus 3. So now it's completely factored. So now I can build my LCD. So I know I need an x. I know I need an x minus 3. I move on to the next term. I have an x minus 3 to the first. Well, I already have an x minus 3, so I'm good. I move on to the next one. I have an x, and I already have an x, so I'm good. So this is my LCD. Now what are my domain restrictions? What can x not equal? Well, if x is 0, then I'd be dividing by 0 here. And if x is 3, I'd be dividing by 0 there. And it's the same for these ones, because this denominator is a combination of those two. So now I need to multiply both sides, or each term, by my LCD. So if I do that, I have 18. Well, let me rewrite this equation out how you would see it, and then I'll come back. Okay, so I've rewritten our equation out. It's in the black ink, and then the LCD is in the red. So I multiplied each term by the LCD. And remember, we can do this because this is an equation. In an equation, we can manipulate it more than just if we were dealing with expressions. So I can multiply through by something as long as I multiply every term by the same thing. So now let's cancel out the denominators. So now recall, x squared minus 3x is just the same as x times x minus 3. So this entire thing cancels with this. X minus 3 cancels with this x minus 3. And then the x cancels with the x. So what am I left with down here? Well, I'm just left with 18 minus 6 times x, because that's all that's left over from that one, is equal to 5 times x minus 3, because the x is canceled out here. So now I'm down to a linear again, and I can just solve this. So this is 18 minus 6x is equal to 5x minus 15. Since it's a linear, I'll move all the x's to one side, all the constants to another. So if I do that, I end up with 33 is equal to 11x divided by 11, and I would have x is equal to 3. I have to go back. I have to look against my domain restrictions. I see that x cannot equal 3. Well, I have x equals 3 down here, so I know that this is an extraneous solution. And since it was our only solution, that means there is no solution to this problem. No solution. Because the only answer we got was extraneous, so it does not work. All right, so no solution to this one. Let's take a look at our next one. So I have 3x plus 6 over x squared minus 4 is equal to x plus 1 over x minus 2. So first step, find the LCD. If all your denominators are not factored all the way, you need to do that. This is x squared minus 4. X squared minus 4 is the difference of squares, which we have run into a lot. That's x minus 2 times x plus 2. Okay? So you have to make sure your denominators are factored all the way to build the LCD. So now let's go through and build it. So I know I need an x minus 2. I know I need an x plus 2. Now let's move on to the next one. This is just x minus 2. Well, I already have an x minus 2, so I'm good to go. What can x not equal? Well, it can't equal 2 or negative 2, because that would make your denominators equal to 0, which we can't do. So now I need to multiply both terms by the LCD. So let's rewrite it. I have 3x plus 6 over x squared minus 4, x plus 1 over x minus 2. I'm going to multiply by our LCD, which is x minus 2, x plus 2, x minus 2, x plus 2. Okay. And remember, you can think of these as over 1 if you wish. And let's see what cancels out. All our denominators should cancel out. If your denominators don't always cancel out, that means something is up with your LCD. So x squared minus 4 is the same as x minus 2, x plus 2. Goes away. X minus 2 goes with the x minus 2. So I'm left with 3x plus 6 on this side, because those canceled. And on this side, on the right side, I'm left with an x plus 1. And what's left over here is the x plus 2 remaining from the LCD. So if we multiply everything out, this is 3x plus 6 is equal to, this is x squared plus 3x plus 2 if you distribute it out. So we have that. Now, since this is a quadratic, this is a square term. So when we have quadratics, we want to move everything to the side of the quadratic term. So I'm going to move everything over to the right side. And when I do that, I'm going to have 0 is equal to x squared minus 4. The 3x's go away. 3x and 3x go away. When I subtract 6, I get negative 4. Well, now I have 0 is equal to x minus 2, x plus 2 when you factor it, because it's the difference of squares. And then you would have that x is equal to 2, negative 2 from here. And just like our last problem, I see that both 2 and negative 2 go against our domain restrictions. So these are both extraneous. So again, this one also has no solution. I probably should not have put these two no solutions back to back, but they do crop up, so we have to take a look and make sure that we're checking our answers against our domain restrictions. So that one is also no solution. I promise the next one will have one. A solution. All right. So 3 terms here, and one of our denominators is a trinomial. So first step, find the LCD. X minus 5 is factored all the way, x plus 6, that's good. X squared plus x minus 30, not good, so I need to factor this. Factors of negative 30 that add up to 1 are an x plus 6, x minus 5. Oh, they're the same as those two. What a coincidence. So, number 1, build our LCD. Left to right, we need an x minus 5. We need an x plus 6. X plus 6 we already got, x minus 5 we already got. That's our LCD. What can x not equal when we go back to check our solutions? X cannot equal 5. X cannot equal negative 6. Good. So now we multiply both sides by our LCD. Let me write that out. Okie dokie. So I've written it out. Again, our original is in black ink. Our LCDs are in red. So what cancels out? X minus 5 with the x minus 5. X plus 6 with the x plus 6. X squared plus x minus 30. Well, we know that the factored form is just this. So that entire thing goes away with both of those. And so what am I left with? Well, I have the x plus 6 left. And that's being multiplied by our 5x plus 4, and that's being multiplied by the x minus 5. And that is equal to, well, we have the 5x plus 5. Well, and both of these went away when we canceled out our denominators, so now we can solve this. So I'm going to distribute out. So this is 5x squared plus 30x plus 4x minus 20 is equal to 5x plus 5. Now, I'm going to move everything to the left side since this is a quadratic. I'm going to move everything to my quadratic term side. So when I do that and I collect all my like terms, I'm left with 5x squared minus 20x minus 25 is equal to 0. So I moved everything to the left side. So you now may think, well, multiply 5 times negative 25 and I get going from there. But remember, when we're factoring things like this, we need to make sure that we are pulling out a GCF if we have one first. And all these are divisible by 5. So I'm going to pull out a 5, and I have x squared minus 4x minus 5 is equal to 0. So now this is a simple quadratic trinomial. And so now I can just find factors of negative 5 that add up to negative 4, and it's negative 5 and positive 1. So I have 5 and then x minus 5, x plus 1 is equal to 0. So now my solutions from each one of those is that I would have that x is equal to 5 from the first binomial and negative 1 from the second binomial. Now I need to check these against my restrictions. 5, no good. -1, -1 works because it doesn't go against our restrictions. So the solution to this is that x is just equal to -1. So this one has one solution. One of our other answer was extraneous, so we only left with 1. All right, let's take a look at this one. 3 terms seems like there's a lot going on, but again, it's the same process. We have to build the LCD first, and then go from there. So let's look at all our denominators. Whew, I can't say that. Let's look at all our denominators and see if they are all factored. 3x minus 2, good to go. 9x squared minus 4. Well, this is a squared term, and there's 2 of them, and there's a minus. So this looks like it's the difference of squares, which it is. So this is 3x minus 2, 3x plus 2. So that's our difference of squares. And then we have 3x plus 2 over there. So 1, building the LCD. Left to right, I need a 3x minus 2. Now onto the second term, 3x minus 2. Already got it. Need a 3x plus 2. Good to go. Moving on, I need a 3x plus 2. Already got it. So what can x not equal from this? Well, if I set each one of these equal to 0, if I move the 2 over, divide by 3, I will get 2/3 on this one. On the plus 2 one, if I move it over, it's -2 when I set it equal to 0. And divide by 3, it would be -2/3. So x cannot equal 2/3 or -2/3. So now we multiply both sides by the LCD. Okay, so both terms have been multiplied by the LCD, so now I can cancel out our denominators. 3x minus 2, 3x minus 2. 9x squared minus 4, remember it's this whole thing, so those all cancel. And on this side, 3x plus 2 goes with the 3x plus 2. And now we need to see the wreckage that is left. See what we're left with. We're left with a 3x plus 2, 2x minus 1 from the first term. Second term, I'm left with a plus 6 minus 2x times nothing, so I just have that left over. So I don't really need this in parentheses anymore, so I'll get rid of that. From our second term, 6 minus 2x, and doesn't get multiplied by anything because those all cancel out, equals, I have the 2x plus 1. And what's left over from our LCD is just the 3x minus 2. So I want to multiply by 3x minus 2. All right, so I need to double distribute these both out. And when I get that, I get 6x squared plus x minus 2. And then I still have my plus 6 minus 2x. And on this side, I get 6x squared minus x minus 2 when I multiply those out. So now I'm just going to consolidate things a little bit over here. I get 6x squared minus x plus 4 is equal to 6x squared minus x minus 2. So I just combine my like terms on my left side. So now, let's take a look at what we have here. I have 6x squared minus x plus 4 is equal to 6x squared minus x minus 2. If I move all my quadratic terms, or move everything to the left side, what do you get? Well, if I move everything over, I end up with 6 is equal to 0. Well, that's odd, and that's certainly not a true statement. 6 is not equal to 0. Well, since 6 is not equal to 0, that means this has no solution. Because when we consolidated everything down, we came up with a false statement. This is false. That means there is no solution. So that's another way you can get no solution, is if you come up with a false statement, like 6 is equal to 0, or 5 is equal to 2, or something like that. So that means there's no solution. Okay? All right, Next up, we have x plus 2x over x minus 1 equals 3 minus x over x minus 1. So let's build our LCD first and foremost. So number 1, build the LCD. Well, you can think of x as just x over 1, so we don't really need any part of this for our LCD, but we do need an x minus 1. And then moving on to the next one, it's also an x minus 1, so we're good to go. So that's our lone LCD. 2, what are the restrictions? Well, x cannot equal 1 from that. So now we need to multiply everything by the LCD. So now everything has been multiplied by the LCD, and let's figure out what we got. Well, nothing cancels here because this denominator was just 1, so we can just multiply this out into x squared minus x. On this side, x minus 1 cancels with x minus 1, so it's just plus 2x equals, well, what do we have here? X minus 1 cancels with x minus 1, and then we have 3 minus x, so we have that. So now I want to move everything to one side of the equation, move it all to the left, and I have x squared plus 2x minus 3 is equal to 0, so I need, can this be factored? Factors of negative 3 that add up to 2 are 3 and negative 1, so I have an x plus 3 and an x minus 1 is equal to 0. So what are my solutions from this is that x would equal negative 3 and positive 1. Now we check these against our domain restrictions. We know x cannot equal 1, so we have to throw this guy out, and our only solution is x is equal to negative 3 for this particular problem. Alright, so on this one I want you to put a little star next to this. Because this one, the reason I'm showing it to you is there's a little trick that can help you out a bit and reduce the size of your denominator. Okay, so pause this for a second and just think about what is the LCD for this particular problem. So pause it, think, and we'll come back. Okay, so hopefully you pause it and you're thinking, what's the LCD? So you might be thinking the LCD is 1 minus x times x minus 1, okay? Well, you could certainly solve this problem that way and do the same thing that we've done. There's a little trick that you can do when your denominators, when your binomials are switched, when they're sort of flip-flopped. I have 1 minus x, I have x minus 1. What you can do is you can multiply one of your terms by negative 1 over negative 1, because you can do this because you're multiplying top and bottom of just that expression, and let's see what happens when we do that. When we do that, we end up with a negative 1 up top, and in the denominator, negative 1 times 1 is negative 1. Negative 1 times negative x is just x. It turns into the other denominator. So now we've simplified this out, and now our denominator of x minus 1 is just our only LCD. Is just x minus 1. It's not two terms anymore, and this can simplify things a bunch when we're doing some more complicated problems. So just keep that in mind, that if your denominators are different because they're just, one is multiplied by negative 1, you can just go through multiply by negative 1 over negative 1 and change it so they are the exact same. So now let's solve this. So and I've multiplied all the terms by our LCD, and let's cancel things out. Oh, we didn't do our restrictions. Whew. What can x not equal? X can't equal 1. Alright, so now let's go back. Cancel, 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 cancel. What am I left with? On the left side, I'm left with negative 1. And here I have x minus 1. And since these two cancel, it's just minus x. Negative 1 is equal to x minus 1 minus x is just negative 1. Well, now I have negative 1 is equal to negative 1. Well, that's a true statement. That's true. And that means there is an infinite number of solutions. And why is this? Why is there an infinite number of solutions? Well, I hope someone asks in class, why are there an infinite number of solutions? We'll take a look at this graphically and see another representation, and you can see why this particular problem has an infinite number of solutions. So after we are done with the entrance quiz, next class, please someone ask why this particular problem has an infinite number of solutions, and we'll take a look at it. X plus 1 over x squared plus 1 is equal to 3/5. So, build the LCD. I have x squared plus 1, and I'm like, oh, let's try to factor this. And then I think to myself, this is the sum of squares. The sum of squares doesn't factor, so this is already as broken down as it can get. So I know I need an x squared plus 1, and over here I need a 5, so I need a 5. So that is our LCD. What can x not equal for number 2? X cannot equal, well, since this doesn't have any real zeros, and this is just a constant, x cannot equal nothing. So there are no restrictions. Restrictions. I can spell sometimes. Alright, so there's no restrictions on this. So anything we get would be a correct answer. So let's solve this. So I have x plus 1. Actually, I don't need to rewrite it for this one because it's just 2 terms and I have lots of space. So multiply this side by x squared plus 1 times 5. Multiply this side by x squared plus 1, 5. Okay, so let's see what cancels out. X squared plus 1, x squared plus 1, and I'm left with 5x plus 1 is equal to, on this side, 5 and the 5 go away, and I'm left with 3x squared plus 1. So now I want to solve this. So I have 5x plus 5 is equal to 3x squared plus 3. This is a quadratic. My quadratic term's on the right side, so I'm going to move everything to the right side. So I have 0 is equal to 3x squared minus 5x minus 2. So now this is a quadratic. There's no GCF. So first term times the last term is -6. Factors of -6 that add up to -5 are -6 and a +1. So I'm going to rewrite this so I could solve it by grouping. 3x squared minus 6x plus x minus 2. So what can I take out of here? I can take a 3x out. I'm left with an x minus 2. What can I take out from here? Well, I can take out a +1. I'm left with an x minus 2. So this is going to be 0 is equal to 3x plus 1, x minus 2. So what would my solutions from this be? I would get x is equal to -1/3 from the first one and 2 from the second one when I set each binomial equal to 0. And since I have no restrictions, those are both answers. So I finally have one that has 2 solutions. So that has 2 solutions right there. Okay, so let's take a look at one more and then we're done. Okay, so let's build the LCD from this one. Let's pretend that's over 1. So I need an x, I need a 1, but we don't write it. Then I need an x minus 4. What are our domain restrictions? X cannot equal 0 or 4. Now we need to multiply everything by the LCD. Okay, what cancels? X cancels with the x. Nothing here. X minus 4 with the x minus 4. So what am I left with? I'm left with x minus 4 times 10 plus 3x, x minus 4 equals x plus 9 times x. So So let's multiply all this out. So I have 10x minus 40 plus 3x squared minus 12x is equal to x squared plus 9x when I multiply it out. So I have a quadratic, so I'm going to move everything to the left side because I have a 3x squared, just an x squared over there. So I'm going to move everything to the left side. So I've moved everything to the left side, and I end up with 2x squared minus 11x minus 40 is equal to 0. So now I need to think of, I need to multiply your first and the last, and this is negative 80. Factors of negative 80 that add up to negative 11 are going to be a negative 16 and a positive 5. So I want to solve this by grouping. So I have 2x squared minus 16x plus 5x minus 40 is equal to 0. From the first two, I can take out a 2x, left with an x minus 8. From the second two, I can take out a 5, and I'm left with an x minus 8. So I have an x minus 8, 2x plus 5 is equal to 0. And my solutions from this are going to be that x is equal to 8. That is an 8. And from this one, if I set it equal to 0, I get negative 5 halves. So those are my two solutions. Neither one goes against the domain restrictions. So I am good to go. So folks, I know that was a little bit long, but I wanted to show you a bunch of different examples and some that have different approaches and different types of solutions. All right, thanks for hanging in. I will see you guys in class. Have a good day.